For which values of p will this equation have two unequal roots? Okay, firstly, we need to rewrite the equation and bring all terms to one side. So we're going to have negative 2x squared plus 4x minus 3. We transpose the p to b plus p equals to 0. Hence, we have negative 2x squared plus 4x plus p minus 3. I'll just put it in bracket for showing that it's c. Ne? Now, we have to write our values of a, b, and c. All right. So we can see that the value of a is basically negative 2. Negative 2, and the value of b is 4, and the value of c is p minus 3. Right. So for two unequal roots, we know that the discriminant must be bigger than 0. Right. Because if I say bigger than or equals to 0, it means I'm allowing for also equal roots. But here they say two unequal roots. So the discriminant can be 0. Now, ladies and gents, let's compute the discriminant. We know that the discriminant is basically b squared minus 4ac, of which we can substitute. Our b we said is 4 minus 4. Our a is minus 2, and our c is p minus 3. And then, here we forgot to square. And then we can see that the discriminant is 16. Negative 4 times negative 2 will be plus 8. Then we have p minus 3. Because this one times that one give us positive 8. All right? And this further simplifies to the discriminant equals to 16 plus 8p minus 24. And the discriminant is equals to 8p minus 8, because 16 minus 24 is 8. This minus that, it's minus 8, right? Okay. But remember, we initially said this guy, the discriminant, must be bigger than 0. So this leads to 8p minus 8 being bigger than 0. Then we can see that 8p will be greater than positive 8. We transpose the minus 8 to the other side. Dividing both sides by 8, we get p is bigger than 1. And that is our answer for the first question. Now let's go and check for the next question. The next question, we want to have roots that are both positive. Ne? Okay. So for the roots to be positive, if all of them are positive, we know that when we add two positive numbers, we are going to basically have a positive number, which means root 1, the first root plus the second root, are going to be bigger than 0. Ne? But the sum of roots in any quadratic equation, it's always minus b over a. You need to remember this. This is very important. Let's check if indeed this is true. So the sum of roots, let's see if the sum of roots will be positive. So we have negative. We said our b is 4. Our a was negative 2. And we can see that the answer is 2, which is bigger than 0. So the sum is always positive, so there is no restriction on p, because the sum of these roots will always be positive in this case. Now we need to check the product of roots. Ne? For this to be, if the two roots are all positive, if we multiply two positive numbers, we get a positive number. So the product of roots must also be bigger than 0. And the product of any two roots in a quadratic equation is given by C over A. The sum is negative B over A. The product is C over A. And we said our C was P minus 3 over negative 2, which is our A, right? And then, if you check here, we want this product, which is P minus 3 over 2, to be bigger than 0, so that we can have two positive roots. Oh, and then here there's a negative, right? Then we have P minus 3 will be less than 0. Why? Because I'm multiplying both sides by negative 2. And remember, division or multiplication by a negative switches the sign. Okay? Perfect. And then we can see that P would be less than 3. But now we need to remember this. Originally, we said that P must be bigger than 1, which means it's from here going there, right? Now we're saying P must be less than 3, which means it's from here going to the left. But the intersection is just this part here. So we always, if we have two conditions, we always take where they intersect. No? So let's check now. So we can see that the solution will be therefore in between 1 and 3. We can see that P is bigger than 1 but less than 3. Right. Perfect. Because if you are outside, let's say your solution is somewhere here, then you are going to have non-real roots. Does that make sense? Perfect. Thank you very much.